Welcome to physics class on motion in a plane, scalar and vectors part 1. Let's see the points to be discussed. Scalars and vectors, types of vectors. We will try to learn the basic or fundamental things about scalars and vectors, and later on we will try to have the different types of vectors. This is an introductory part, and we need to know the terminologies that will be required for the study of this chapter. Okay, so now we will try to learn about some of the terms, okay, and definitions, the type of the vector quantities and all. Now let's see about a scalar quantity. A scalar is a quantity which has magnitude only but with no direction. So a scalar quantity is a physical quantity which doesn't have no direction at all, but it will have magnitude. Now physical quantity means any measurable quantity. Any measurable quantity which can be specified by a scalar, which can be specified by a magnitude, then that type of quantity is known as scalar quantity. For example, mass of an object. When I say mass of an object is 5 kg or 3 kg, it doesn't have any direction. Irrespective of direction, it will have its value of that 5 kg. That 5 is a magnitude, okay, and kg is a unit. For example, like that of the path length or distance travel, area, time taken, then frequency. These are all scalar quantity which doesn't have direction, but it can be specified by only magnitude, right? Now let's hear about a vector quantity. A vector quantity is a physical quantity which can be specified by both magnitude and direction. That means a physical quantity which can be determined, okay, both by magnitude and direction, then that type of physical quantity is known as a vector quantity. So in a vector quantity, it will have magnitude as well as direction. Only magnitude or only direction cannot be specified, but in order to specify the vector quantity, both magnitude and direction will be required. For example, position vector is a vector quantity. I will tell you about the position vector later on, but let me give you only a brief idea only. A position vector is a vector drawn from the origin up to the position of that particular vector. So it is a vector quantity because it has a definite magnitude as well as a definite direction. From where to where? From origin to the position of the body. Now then displacement is also a vector quantity. Displacement, velocity, acceleration, force, these are all vector quantity, okay, because they have both magnitude as well as direction. Notation for a scalar quantity and vector quantities. Let's see. Let A be a physical quantity. Depending upon whether it is vector or scalar, it is represented as follows. So for a scalar quantity, it will be written by a letter, okay, it will be represented by a letter alone, like this, like a letter. Suppose if A is a vector, then A will be written simply as letter A, like this. It may be capital or small letter, doesn't matter, but here it is a capital letter, okay. But in the case of a vector quantity, it will be represented by a letter, and we have to put one arrow above it while writing, because this vector quantity can be represented by a bold letter if it is type, or if it is in the computer, then we can represent it by a bold letter. But we can't make it bold by writing like this. It will take long time if you, in order to make this bold like this, right? So in order to represent a vector quantity, instead of making a ball like this while writing, we need to write it the letter which represents the vector quantity with an arrowhead above it. Got it? But in the case of a scalar quantity, it represents only a magnitude. Okay, so what happened, it can be written by a letter alone like this, a, or it can be written with the modulus, or you can call it this as absolute value. Okay, absolute value of the letter a, that represents what, a scalar quantity. So in a scalar quantity, it can be represented by a letter alone, but in the vector quantity, we need to write the letter with an arrow above it, okay, to represent that vector quantity. Now let's see the differences between the vector quantity and scalar quantity. So let's see in the definition or meaning of these two. Any physical quantity that doesn't include direction is known as scalar quantity. That means a physical quantity which can be specified by magnitude alone, we call it that as a scalar quantity. That is about this one. Now vector quantity. Vector quantity, any physical quantity which can be specified both by magnitude and direction. Magnitude and direction, we call it that as vector quantity. The scalar quantity is what, one-dimensional, whereas vector quantity is multi-dimensional. Now scalar quantity can be changed by changing magnitude only, whereas in the vector quantity it can be changed by changing magnitude or direction. Okay, it can be changed, that means vector quantity can be changed either by changing the direction alone, or magnitude alone, or by changing both. Got it? So there are three ways to change a vector quantity, but in the scalar quantity, by changing only the magnitude, scalar quantity can be changed. But in the case of vector quantity, a vector quantity can be changed in three ways, either by changing direction alone, or by changing the magnitude alone, or by changing both. Suppose if you change the direction of a vector quantity, then we will say that a vector quantity has been changed. Or if you change it only the magnitude by not changing the direction, then also we will say that a vector quantity has been changed. If you change both magnitude as well as direction, then also we will say that the vector quantity has been changed. Now this scalar quantity, now let's consider about the operation. Okay, a physical quantity follows or obeys ordinary rules of algebra. So those are multiplication, those division, subtraction. Okay, those thing will be what followed while operation of this scalar quantity. Scalar quantity can be added, okay, can be what subtracted, can be multiplied, can be divided. Now in the case of this vector quantity, it doesn't follow this vector simple algebra, rather it will follow what, vector algebra. In the case of vector quantity, we will not follow that simple algebra of that multiplication, division, addition, subtraction, rather it will have to follow that vector algebra. What is this vector algebra? Actually we will tell you later on, but you can also say that addition and what, subtraction or multiplication or division, that will follow the geometry, not with that simple algebra. Okay, now in the case of this, scalar is a very simple quantity, whereas this vector quantity is a very complex quantity. So those are the differences between what, scalar quantity and vector quantity. So if you are asked to write the differences between scalar quantity and vector quantity, then you can write these different points. You can pause the video and you can copy down in your notebook also. Okay. Now, how to represent this vector quantity? Let's try to see. A vector quantity is geometrically represented by a directed line segment with an arrowhead. Okay. Suppose if there are 2 points like this, 2 points, and if you want to represent a vector quantity, then this line segment will give you the magnitude. Okay, the magnitude of the vector quantity will be represented by the length of the line segment. That length will give you the magnitude. Okay, and the direction will be given by what? The direction will be given by the arrowhead. That means this vector quantity will be represented by like this. For example, a vector. Okay, then the magnitude of this a vector will be given by what? The length of the line segment. This length will give you the magnitude. So in the vector quantity, magnitude can either be represented by a single letter like this without an arrowhead, or it may be represented by the absolute value or the modulus of that given vector. Modulus. Okay, so this will give you the magnitude. And if you want to write it this a vector, then we can write it as a with a cap like this. What is this a cap? This a cap is a unit vector, and it will give you the direction, okay, of this vector quantity. A unit vector is a vector of whose magnitude is unit. That means magnitude is 1, and the direction will be in the direction of this given vector. Okay, so generally we say that unit vector will give you the direction of the vector quantity. So see, in this what happened, O is the starting point and A is the terminal point. We call it this O as the initial point and A as the final point or terminal point. Sometimes this O is also called as tail, and the terminal point A is also called as what? Head of the vector quantity. O is a tail, A is the head, or you can call O as the initial point because it starts from here and it ends at the point A. So we may call it this point A as the end point or terminal. Now the length of the directed line segment is called the magnitude of the vector quantity. The length of the line segment means OA. OA is known as the magnitude. So we generally represent OA like this if it is a line segment like this. So this line segment will represent the magnitude of that vector quantity like this. The direction of the arrowhead of the line segment represents the direction of the vector quantity. So direction is from where to where? Direction is from O to A, but not from A to O. Rather, your vector A vector, it should be one arrow there above it. So your A vector is directing along this OA. So your arrowhead will represent the direction of the vector quantity OA. And OA, if you are going to represent the A vector, then it is represented here as A vector like this. So a letter above, okay, it, if one arrow is there above the letter, then this will represent a vector quantity. A vector quantity, and if it is a vector quantity, it will have magnitude. Magnitude will be given by the length of this line segment, and the direction will be given by the arrowhead. Here in the diagram, it will be from O to A. That means it will be directed along like this. Yes. Now let's see the different types of vectors. They are coinitial vectors, coterminal vectors, coplanar vectors, null vector, unit vectors, like vectors, unlike vectors, negative vectors, fixed vectors, free vectors. There are so many lots of terms to be discussed. Okay, I will tell you one by one, and you can even pause this video and you can note down those different things about these different terms. Okay, co-initial vector means those vectors. Okay, those vector means it may be of more than it may be two or more than two. Those vectors are known as co-initial vectors if they have the same terminal, the same initial point, I mean. Okay, but before that there are other more terms to be discussed about one-dimensional vector along x-axis, y-axis. Okay, like this. Two-dimensional vector, that means, or we may call it as plane vectors in xy plane, yz plane, xz plane. Space vector, that means three-dimensional vectors, that means along x, y and z. Okay, axis. So as I told you that about of the co-initial vectors, those vectors of whose initial point are at the same point, we call it that as co-initial point. Co means similar, okay, or equal or same, you can say. So co-initial vector means those vectors, two or more vectors, if they are having or sharing that common initial point or same initial point, then they are known as co-initial vectors. Now here OA vector, this first vector which is represented by a small letter A. So this A vector, the starting point or the initial point is O. For the letter, for the other vectors, this OD is also one of the vector. OB is also one of the vector here. Like that, OE, another vector. OC. So all these vectors are having the same initial point, and so such type of vector we call it as co-initial vectors. So two or more vectors, if they are having same initial point, then those vectors are known as co-initial vectors. Next is coterminal. Likewise here in the co-initial, if two or more vectors are having the same terminal point, then those vectors are known as what? Coterminal vectors. Okay, these are all vector quantities. Got it? Yes, those vectors, two or more vectors which are having same terminal point, they are known as coterminal vectors. Okay, next is coplanar. Coplanar means two or more vectors. Okay, if they lie along on a same plane, if they lie along if they lie on a same plane, then those vectors are known as coplanar vectors. It may be of same length or maybe of different length. Rather, I mean, the vectors may be of same magnitude or different magnitude, or it may be in a different direction, doesn't matter. So what happened, as long as these vectors lie on the same plane, then those vectors are known as coplanar vectors. Okay, so as I said, it is what, irrespective of their magnitude and direction. Only thing is that they should lie on the same plane. Got it? Next is about null vector. Null vector, we sometimes call it as also what, zero vectors. Any vector which has direction but no magnitude, that means magnitude is equal to 0. Okay, we call it that vector as what? Zero vector. Got it? So your null vector will be represented by a zero vector like this. What does it mean? It means that it will have zero magnitude, but the direction will be in any direction. Okay, so it may have arbitrary direction. Okay, we can't say that this zero vector is pointing in a particular definite direction. So a vector of whose magnitude is equal to 0, we call it that type of vector as null vector. Velocity of a standing still train is a null vector. Okay, or when we say that if a if an object start from here and if it comes here at that initial point again, so its initial and the terminal point are at the same point. So the displacement, okay, the displacement of this motion, that will be from the initial point to the terminal point, as it is on to the same point, the line segment representing from initial to terminal, that will be equal to 0, and that type of vector will be represented by the 0 vector. Okay, so this 0 vector is a vector of whose magnitude is 0, but the null point, the direction will be at any direction. Okay, let's see about the unit vector. As I told you that unit vector is a vector of whose magnitude is unity, that means of whose magnitude is 1. Okay, that is known as unit vector. So how to represent a unit vector? Let's see. If a is a vector, for example, if small a is a vector like this, then its unit vector will be represented by what? A cap. We call it this as a cap. So this cap represent, that is a vector quantity, and this a cap of whose magnitude is equal to 1. Got it? So your a vector can be represented by what? A cap. Unit vector of this a vector will be represented by this. Got it? But its magnitude is what? A. So let me write a here like this. Got it? So this represent, that a cap represents the unit vector of vector a. We read this a with arrowhead as vector a or a vector, you can write it. Okay, now this a cap, what does it mean? It means that a cap can be written as what? Your a cap can be written as a vector divided by a. What is this a? A is nothing but this is the magnitude of this a vector. Got it? So a vector, okay, divided by its magnitude will give you the unit vector, this one. Got it? Suppose if you know the vector quantity, if you know its magnitude, then a vector divided by its magnitude will give you nothing but the unit vector. So this unit vector will give you only the direction. If you divide a vector by its magnitude, we get the vector of that unit vector of that vector. Okay, that is what it is given here. Therefore, unit vector a cap, where a cap modulus is called the magnitude of the vector. Either you can write it that modulus of a cap, or simply by the letter a without any cap or arrow, that will represent the magnitude of that vector, right? Now let's see about the like vectors. Like vector means it has two or more vectors, okay, pointing or directing along the same direction are called like vectors. That means you can also say that parallel vectors are like vectors. Parallel vector means directing along the same direction. Okay, these are known as what? Like vectors. So here in the diagram also, your BA and DC are like vectors, because these two are parallel lines and the directions are also parallel, okay, toward BA, toward DC, like this. So this BA vector and BA vector means it will be represented by like this, BA vector and DC vector. These two are parallel vectors, so we call it them as what? Like vectors. BA vector and DC vector are like vectors. Now parallel to one another, the properties, okay, two vectors will be parallel to one another. Magnitude may be of same or different, but it will be along the same direction. Okay, these are the properties of like vectors. the like vectors will be parallel to each other. It will be directing along the same direction, and their magnitude may be of different or same, doesn't matter. So irrespective of their magnitude, if two vectors are parallel and directing along the same direction, then those vectors are known as what? Like vectors. Let's see about the unlike vectors. Any two or more vector, you can say, parallel to one another and acting in opposite direction, that means anti-parallel. Okay, those vectors are known as what? Unlike vectors. It's just like that there also, in the case of these unlike vectors, it will be parallel, no doubt, but the direction will be opposite to each other, and it may be of same magnitude or different magnitude. That means irrespective of their magnitude. Okay, it is given here just like that. You just see. Okay, pause it the video, and if you want to note it down. Now let's see about the negative vectors. If a vector is said to be a negative vector for a given vector, then that vector of whose magnitude is same with the given vector but the direction opposite to the given vector, we call it that as negative vector. Suppose a vector is given like this. A vector is given like this, a vector like this, in this way. Let's take it that this is let's see, P. Let me write like this. So your OP vector is nothing but this is vector A. Suppose if you are going to write the negative of this vector, then that negative of this vector A will be represented by minus OP, right? And in the vector notation, it will be minus AP like this. So this minus AP will be represented by this similar length or equal length, that means from O to P of same magnitude, same line segment, length of the line segment will be same, but the direction will be opposite to the given vector. So this vector PO, it will be represented as what? PO, from P to O. Previously it was from what? O to P. Now it will be from P to O, and this will represent what? That negative of the vector. So this will be represented by what? Minus A vector. Got it? So this will represent what? Negative of the vector, as it is also expressed here. Your CB and CD, CD and AB. Okay, DC is a given vector, and if you want to express it, the negative of it, then it will be what? So this is the given vector, for example, and if you want to express the negative of this vector, then it will be of same magnitude with this given vector, but the direction will be what? Opposite. That will give you what? The negative of this given vector, right? So what are the properties? The original vector and its negative vector will be of same magnitude, as I said, but the direction will be opposite to each other. Okay, yes, every vector will have a negative vector. Every vector can have the negative of that vector. That means it can have the same magnitude, opposite in direction, right? Now let's see about the axial vectors or one-dimensional vector. One-dimensional vector means in order to specify that vector, if a particular direction is required, okay, then we will call it that as one-dimensional vector. Now vector acting along x-axis, y-axis or z-axis, okay, it is in a particular direction, x-axis, y-axis, then that type of vector is known as what one-dimensional vectors. Okay, not only this x-axis or y-axis, it may be in any direction, okay, not in a particular defined direction, rather it may be like this also. Got it? If it is what along a particular direction, then we will call it that as what axis vector or axial vector. That means in a one direction fixed, Okay, one dimensional means in order to specify that position, if we require only one physical quantity, then we will call it that as one dimensional. So in the case of that of this axis, x-axis, y-axis and z-axis, okay, so suppose if you are requiring that particular vector along in a definite direction, then that type of vector we will call it that as axial vector. Got it? So either it may be what, x vector, or it may be along y, that we call it as y vector, or it may be along z, it may be called as what, z vector, like that. Now two-dimensional vectors, the vectors acting, okay, in xy plane, yz plane, zy plane are known as two-dimensional vectors. Why we require two what axes to specify what, that position of the vector, okay, either it may be finding of that initial point or it may be of final point. So to specify those two those points, okay, we require to specify two things. Suppose in order to specify, suppose this is along x-axis like this, and if it is y like this, so this plane, your plane of the screen, that is what, xy plane. Got it? So if a vector is here like this, in order to specify this initial point, we require the x value, rather you call it that as abscissa. You will know what, the ordinate, then only you can specify this point. Suppose if this point is what, representing by x y like this, then x means this, y means this part, right? So after knowing this x and y, then only you can specify this point, right? So in order to specify this particular point, we require two things, two variable, x value and y value. X value we call it as abscissa, y value we call it as ordinate, okay. And if you want to specify this terminal or final point also, you need to know two what, values, x value and y value of this point. We call it that as coordinate, right? So in order to find this position or final position, we require this coordinate, two variables. So we call it that as what, two-dimensional. Why? Because we require two variables. Got it? So those vectors lying on the plane, either it may be xy plane like this, or it may be of what, yz plane. Yz plane means this plane, we call it that as yz plane. Or it may be of xz plane also, it may be of xz plane. Xz plane is this plane. Got it? So either it may be lying here like this, the vector quantity, I mean your vector may be lying here like this, or it may be lying here. Got it? So those plane lying on the plane, we call it as what, two-dimensional vectors, right? So here this is about the space vector. In the case of space vector, you can call it these as what, three-dimensional vectors. If any vector possesses components along the three axes, x-axis, y-axis, z-axis, such vectors are called as space vectors. Okay. Now just to know it details, let me tell you what is this I cap. I cap is nothing but this is the unit vector along what, x-axis. J cap is the unit vector along y-axis, and k cap, okay, is the unit vector along z-axis. What are these? I, j, k cap. I cap is a unit vector along x-axis, j cap is a unit vector along y-axis, and k cap is a unit vector along what, z-axis. Suppose if your A vector is represented by OE, that means this vector OE is nothing but this is your A vector, for example. Then this OE, okay, as it is along this in the space, what happen, it will have its component along x-axis, another along y-axis, and another along z-axis. I'm sorry, this should be instead of this, it should be y-axis. Okay, while making it was wrong, so it should be of y-axis and this should be of z-axis. See, you will see x-axis here, y-axis, z-axis, right? So if you make it this starting point of this vector OE as the origin, and if you draw three mutually perpendicular axes, what we call as x-axis, y-axis, then what happen, OC will represent what, your x component OC, plus then OA will represent your component of OE along y-axis. So we can write it as what, OA vector, okay, OA vector, plus OG will represent the component of this OE along z-axis, like this. So what happened, your OA, if this okay, E, the point E, the coordinates may be of what, AX, AY, okay, and AZ. If these are the coordinates of this point E, then what happened, your OC will be equal to what, AX. Your OA will be represented by the length AY, and OG will be represented by AZ. Then your vector quantity, what, OE can be expressed as what, OE can be expressed as like this. Let me write it, okay. OE is nothing, it will represent your vector A, and OC will represent what, its magnitude is AY. So it will be AX, sorry, AX, magnitude of OC is what, AX, and the direction, okay, will be given by the I cap as it is along x-axis. So your OC vector will be equal to what, AX I cap. Similar to that, OA will be equal to what, AY J cap, and OG will be equal to what, AZ K cap, like this. So let me tell you again in the next slide, okay, in details. Now I will show you the next slide. So this space vector can be represented in Cartesian coordinate form, okay, like that. These are nothing but whatever I have told you here, these are all inside this, okay. But let me take to the next slide so that I can tell you in details. Now, as I said, this OE represent a vector quantity. OE will represent a vector quantity. OE will represent a vector quantity, and the direction of the OE is along this, okay. So your OE, as I said, OE vector, this will be equal to what? Now this point OE, if suppose you take a cuboid, okay, and this cuboid will be representing the body diagonal, okay, this will represent the body diagonal. O and E are the diagonals, but it is not lying on one face, okay. This line OE will be inside the body itself, and these E and O are the opposite vertex inside the body itself. Got it? This point G, okay, this point G and B are also the opposite diagonals, and the diagonal opposite vertex, and the diagonal will be also known as body diagonal, okay. Likewise, O, G and E will be on the same face, and that line GE will call it as what, this face diagonal, okay. From G to E, if you draw it like this, this is on the same face, right? Then we will call it this GE as face diagonal. It is not like that here. It will be what, Directing from where to where? From this O up to this point E. So if OE represents the vector quantity, then what happened? The component of this vector quantity along x-axis, y-axis and z-axis will be of what? It will be of like this. So now let's represent it that OE vector, okay, will be equal to what? OC vector, as I said in the previous slide, OC vector plus OA vector plus OZ vector, right? So these OC, OA and OZ vector are known as component of this given vector OE. Got it? Now the sum of these three vectors will give you this single vector. So this single vector is known as resultant vector. Resultant vector of these three vectors. And on the other hand, if this vector can be represented as the sum of two or more vectors, then those two or more vectors are known as component of this given vector. Got it? Yes. So OC will be represented by what? OC will be represented, this OC will be represented by what? AXI cap. That means the length of OC is equal to AX. And in order to represent a vector quantity, we require a magnitude as well as direction. So magnitude is what? AX, and a direction is what? I cap. I cap is a unit vector along x-axis. Got it? And along y-axis it is denoted by j cap, right? J cap. And along z-axis it will be represented by what? K cap, right? So if the magnitude of these from O to A, if it is represented by AY, then your OA vector will be represented by what? AY j cap. And that of OZ, okay, this vector will be represented by what? If the magnitude of OZ is denoted by AZ, then what happened? AZ k cap will represent what? Your OZ vector, right? So instead of writing like this, you can write as if OE represents a vector A, then it will be equal to what? The component of A along x-axis, the component of A along y-axis, and the component of what? A vector along z-axis, that will be denoted by AZ k cap, like this. So we call it this as the component of A along x-axis, component of A along, A vector along y-axis, component of A vector along z-axis. So the sum of these three components will give you the given vector A. So if like this, if a vector is given and if you can draw what? X-axis, y-axis, z-axis, okay, and if you can construct a what? Cuboid with the body diagonal, okay, as the given vector, then the side of the what? The length will give you one of the component, breadth will give you one of the component, and the height will give you one of the component, okay, the height of the that cuboid. Okay, I'm telling you again, if a vector is given, okay, if a vector is given and with that given vector, if you make it or if you can construct a cuboid of whose diagonal, body diagonal is with that of the given vector, then the length of that cuboid will give you one component, the breadth of that cuboid will give you another component, and the height of that cuboid will give you the other component. Either it may be x-axis, y-axis, z-axis, like that. So the sum of those three components will give you that given vector. Okay, that is all about it. And with that, we will come to the end of this today's class. Okay, thank you.